In this today's video, we'll be presenting you health rate monitoring over internet using IoT devices, Arduino and ThingSpeak. Actually, we are using pulse sensor and temperature sensor that will measure BPM value and temperature, and we'll be sending it over internet using ESP8266, and you can check the data staying at any part of the world. So let's get it started. So let's learn about the pulse sensor. This is pulse sensor from pulsesensor.com that has photodiode at the top of the point that detects the blood capillary contraction and relaxation, which measures the pulse rate. This is the front side, which is attached to the skin, and this is the back side, which glows. You can see there are three different pins. The first pin is ground, that is black in color, then VCC pin, and analog pin that is given to analog input of Arduino Uno. This is how the gripping is done on pulse sensor. The pulse sensor that has heart shape is the place where finger is placed. This is LM35 temperature sensor, which will measure the temperature. The first pin is VCC pin with 4 to 20 volt input. The second one is output and third one is ground. This is very accurate temperature sensor and does not require any calibration. Now we will be interfacing this pulse sensor with ESP8266 along with temperature sensor. ESP8266 has 8 pins. The pin 1 is ground and pin 8 is VCC pin, which requires 3.3 volt. We have TX and RX, and there are 3 GPIO pins, that is GPIO 0, GPIO 1 and GPIO 2. The components required for this project are Arduino Uno board, ESP8266 Wi-Fi module, pulse sensor, LCD display, register, LED, breadboard, jumper wire, and LM35 temperature sensor. Use 2 resistors, one of 2 kilo ohm and another 1 kilo ohm. This is circuit diagram. We have connected pin number 12, 11, 5, 4, 3, 2 of Arduino to LCD pin, and analog pin A0 and N1 is connected to pulse sensor and LM35 temperature sensor. TX and RX of ESP8266 is connected to pin number 9 and 10 of Arduino Uno board. We have used 2K and 1K resistor for dividing the voltage. For example, ESP8266 runs on 3.3 volt, so 2K and 1K divides the voltage. This is how we have assembled the circuit on breadboard. We have Arduino Uno, ESP8266, pulse sensor, an LED for indication, 16:2 LCD, and a temperature sensor. Now we will connect this circuit to computer. This is the code. The coding is 12, 11, 5, 4, 3, 2 is LCD pins, and we are measuring pulse and temperature. Now this is the string. We need to input this string. I will explain later how to enter this string and where to get this string. Pulse pin is A0, LED blink pin is 7, and 13 is the default pin that will blink. Since the programming is very long, so I will not be explaining each and every point. And this final thing is about the measuring temperature. That is how the temperature is measured via A1 pin. Go to ThingSpeak.com. If you haven't created the ID, click on sign up. Else, if you have created, click on sign in. Enter your email address and password, and finally sign in. Create new channel. Write the name of the channel. For example, I will be giving patient monitoring data. We have measuring 2 fields, that is pulse rate and temperature. So give pulse rate in BPM and temperature in Fahrenheit. After that, we need to add widgets as well. So click on add widgets. Click on gauge. Now click make 2 different gauges, one for pulse and another for temperature. what is the minimum pulse rate? So it is 60 and I am giving 200. Tick interval should be 20 to 30, anything whatever you like. And since IoT data is only updated after 15 seconds, so select it at 15. Now you can see the pulse rate gadget is designed. Now we need to adjust the gadgets of temperature as well. So I am giving the name body temperature. It is for field 2. So the body temperature is maximum is 60 to 120. I am assigning the value. You can assign anything according to the accuracy. The unit is Fahrenheit. So give Fahrenheit. Tick interval, give anything. So we have two gadgets created. Now go to API keys. Copy this key, that is the right API key. Paste it over your Arduino program. Now compile this code and upload it to your Arduino Uno board. So I am directly uploading it. So it is uploading is done. Now after you upload, you will be seeing this on your LCD screen. It will initialize and it will get data. Getting data might take a few seconds. Now put your hand over both the sensor, that is pulse sensor and temperature sensor. So you can see the BPM and temperature both are displayed respectively. Now open serial monitor and select baud rate as 115200. So you can see it is displaying both the BPM and temperature, and also you are seeing get update API key. Now this is very important. If it is not displayed on serial monitor, no data will be sent to internet. So make sure get API key updated is updated on this serial monitor. So it is working actually finally. Now the same data will be displayed on ThingSpeak. So go to private key. Now you will be seeing the data what is recorded. You are even seeing the body temperature pin is moving and BPM pin is moving as well, depending upon the chart. I have fastened the video because after 15 seconds the data is uploaded. So you can see the same BPM and temperature is even displayed on LCD screen. Because of the calibration issue, the BPM and temperature value is rising or varying so differently. This is the data as you are seeing. Now you can monitor this data staying at any part of the world if you have field ID or channel ID of your IoT ThingSpeak. This is how body temperature and pulse rate can be monitored using IoT. Thanks for watching. For more, visit my official website www.howtoelectronics.com.